Okay, folks, let's take a look at page 85, and we're talking about irrational numbers. So in this case, we have our example, which is we know x plus y is equal to root 2 and x squared plus y squared equal to 6, and we're trying to get xy. So notice that if we do x plus y to the power of 2, this is equal to x squared plus 2xy plus y squared. And then you notice that I can see the xy coming here, but then I have the x squared plus y squared. So take a look, if I subtract the x squared plus y squared, and then the answer I divide by 2, I will be able to get the xy. So that's just the idea over here. And that's what this is trying to show us. Okay, so with that being said, let's try question number 3. So question number 3, we have x minus y is equal to root 3, and then x squared plus y squared is equal to 5. So all we need to do in this particular case is that we are going to x minus y to the power of 2 minus x squared plus y squared. Okay, but in this case, what we'll be getting is a negative, right? So then we're going to put a negative at the front, divided by 2, and then we'll be able to get, if you substitute a number root 3 into this, to the power of 2 is 3, minus, and this is 5 over 2, and don't forget about the negative sign. So then it will be just 1, okay? So page 85B. All right, so I'm going to be working on question number 2. The reason why is that a lot of you guys probably forget how to do this. So just so that we can expand the formula. So this one, the formula is x to the power of 3 plus 3x squared y plus 3xy squared plus y to the power of 3. And we already know that x squared plus y squared is equal to 5, and then x plus y is equal to root 3. So how do we handle this question? All right, so what we're going to do first is we're going to establish this, and we need to get rid of this one over here. But if you look at this one is really 3xy times x plus y, right? If you factorize it, it will be as easy as that. So in this case, we know that the x plus y to the power of 3 is root 3 to the power of 3, which is 3 root 3. And if we minus 3 times, according to question number 1, we'll be able to actually get xy. I'm going to spoil this for you guys. Xy is equal to negative 1. The same method how we do these ones too, okay? So this is negative 1. So then all I need to do is 3 times negative 1 times root 3, and then the answer will be 3 root 3 plus 3 root 3, which is 6 root 3. So that's for question number 2. For the other 2 questions, it will be the same way. You have to combine them together and use the x squared plus y squared, or the x plus y, or the previous answer you get, xy, for example, and to get the answers, okay? Let's move on to page 89A. All right, so page 89, let me just get to that page as well. Page 89A, okay. Page 89A, there we go. All right, we got it. So this is also the attribute of irrational number as well. So solve the following square root when x greater than 3. It will tell you that if it's greater than 3 or not. If it's greater than 3, basically it means that x minus 1 is going to be greater than 1. So if we solve the square root over here, in this case, this is the square over here, so it will become x minus 1. So when x is greater than 3, which means that x minus 1 is also greater than 0, right? So when we solve the square root, it will just become x minus 1. And you might want to ask, what if, right, the number is smaller? So I'll show you what happens when the number is smaller. This applies to question number 1 and question number 2 over here. So let's take a look over here. So from the example, we know that when x is greater than 3. So however, you see, this is minus 5. So what happens in between 3 and 5? If, let's say, you have a number that's 4. So if 4 minus 5 is going to be negative 1. So the square root, the square of 4, the 1 will be, negative 1 will be 1, right? So then after I solve the square root, it will still be 1. So how do I represent that? According to our example over here, it will be x minus 5 when x is greater or equal to 5, of course, because if you have x equal to 5, you would just get a 0. However, it will be a negative number for x minus 5 if you solve it, because that makes sense. If I have my x as 4, 4 minus 5 is negative, but you know, when you solve the square root, it cannot be a negative number. It can only be an imaginary number, right? So for question number 1 on page 89, it says that when x is greater than 2. So we're going to set that when we open the square root, it's either going to be x minus 3 or it's going to be negative x minus 3. The most important part is what we put afterwards. So in this case is when x is greater or equal to 3. And in this case is when 2 is smaller than x and smaller than 3. So basically whatever is in between the x greater than 2 and the number 3 over here. Similarly, for question number 2, we're going to do the same thing. So we have x minus 4 and negative x minus 4. And what happens with this? This is when x is greater than or equal to 4. And this is what happens when 2 smaller than x and smaller than 4. Okay? All right. Let's move on to page 90. And in this case, we have a little bit more complicated radical equation over here. So let's take a look at question number 1, 2, because if you know question number 1 and number 2, it'll be pretty easy for you to solve for the following as well. So when we take a look at question number 1, it's pretty simple. We just add these two together. So we find the x root 7 plus root 3, root 7 minus root 3, plus root 7 minus root 3 over root 7 plus root 3. In these two scenarios, we know that the LCM for the two equations will be root 7 minus root 3 times root 7 plus root 3. If you guys did the previous pages properly, you will know that this is actually equal to root 7 squared minus root 3 squared, which is just the difference of a square equation or formula they're using. So 7 minus 3 is equal to 4. So if that's the case, let me just move this around. Sorry. All right, there we go. So let's put over here, right? So when we expand it, this will be equal to, on the top, because my LCM is root 7 minus root 3 and root 7 plus root 3. So then the root 7 plus root 3 will go on the top, become root 7 plus root 3 to the power of 2. On the bottom, it's going to be 4, just like how we did over here, and plus root 3 to the power of 2. Same idea how you get the root 7 minus root 3 to the power of 2 over 4. And so the bottom will become 4. And if we expand it, it will become plus 10 minus 2 root 21. Again, if you don't know how to expand it, it will basically just follow this formula, right? X squared minus 2xy plus y squared. In this case, the x and y will be root 7 and root 3, okay? Once we simplified everything, it will be 5, okay? So same idea for x times y, you just have to multiply them together, and you realize that when you multiply these two together, when you multiply x and y together, the top will actually reduce with the bottom. So it's actually really easy, right? So if, let's say you multiply these two, the bottom one, top one, 1, 1, 1, 1. So the answer will be just 1. Similarly, with question number 3 and number 4, let's find the LCM first. You will see that the construction of that, for example, in question number 4, xy, x to the power of 3 plus y to the power of 3. We already discovered how do we do x to the power of 3 plus y to the power of 3. This is actually equal to x plus y to the power of 3 minus 3xy, x plus y. Okay, and the bottom will be xy. And you already know xy. And you know that x plus y from the first equation, which is equal to 5. 5 to the power of 3, and minus 3 times, and this xy is equal to 1, times x plus y. X plus y is 5 again, so then eventually you will get your answer as 110. Okay, so hopefully this helps you guys understanding from page 81 to 90. If you have any question, please let me know.